So in this question, you are going to calculate the relative atomic mass of M of the metal hydroxide. So here is the information. We have a metal M hydroxide. So from the chemical formula, we will know about that for the metal M, it is two positive. So with a positive 2 charge, and we have now 2.86 gram of metal hydroxide, and it dissolved in water and made up to 250 cm cube solution. That is the volumetric phase. And afterwards, we withdraw 25 cm cube using the 25 cm cube pipette, and then put in the clinical phase. And finally, titrated with an hydrochloric acid with known concentration, then that is a standard solution. So it tells you that we use up 30.4 cm cube of hydrochloric acid to finish the titration. And based on the information provided, we are going to calculate the relative atomic mass of M. So before we do the calculation, first of all, again, in your mind, you need to have such diagram. So HCl will be a standard solution, and we withdraw 25 cm cube of the metal hydroxide solution, right? 25 cm cube metal hydroxide solution, right? So before we do the calculation, first of all, write down the chemical equation. So here will be the chemical equation. So, and we will form, so since we know M will have two positive charge based on the chemical formula, okay, and we will get CO2 and also water. And we balance the equation, and we will get such a this equation. Okay, so afterwards, what we need to do is calculate the moles of HCl reacted. So mole of HCl reacted will be, we have the volume 30.4, and we have also the concentration. And finally, you will get, okay, the number of mole, and you will get 3.04 times 10 to the power of negative 3 moles of HCl reacted. So afterwards, we need to determine the number of moles of metal hydroxide in 25 cm cube, right? So the moles of metal hydroxide in 25 cm cube, okay, will be 3.04 times 10 to the power of negative 3. Since it is 2 to 1 ratio, 2 acid will react with 1 metal hydroxide. So we need to divide by 2. Okay, and we will get 1.52 times 10 to the power of negative 3. So we have such number of mole of metal hydroxide in 25 cm cube, right? And then we need to trace backwards. In 25 cm cube, we will have 1.52 times 10 to the power of negative 3 mole. In 250 cm cube, okay, so the moles of metal hydroxide in 250 cm cube, we need to times the number of mole by 10, right? And you will get 0.0152 moles of metal hydroxide inside 250 cm cube. And finally, the number of mole of metal hydroxide in 2.6 gram will be equals to the number of mole inside 250 cm cube, right? Because we just directly dissolve this compound into 250 cm cube. So the number of moles should be the same. So inside 2.6 gram, we also have, in 2.6 gram, we also have 0.0152 moles, okay, of MOH2. And afterwards, we calculate the molar mass of MOH2. So how can we calculate the molar mass? Again, okay, we have the mass, we have the number of mole. So how can we calculate it? So the molar mass will be 2.6 divided by 0.0152. So that is the molar mass. And you do the calculation and you get 171 as the molar mass. So finally, what you need to do is, because you are going to ask to calculate the molar mass of M, right? So the overall molar mass is 171. So the relative atomic mass of M, then it will be 171 minus 16 plus 1 times 2. What is 16 plus 1? That is the molar mass of hydroxide. And we have 2 hydroxides, so we times 2. And finally, the M will be 137 gram per mole. So that's the calculation of calculating the relative atomic mass of a metal based on the titration result.